So here it has been told that L and M are 2 points with position vectors 2a vector minus b vector. So here, suppose this is the point L and this is the point M. So let's suppose this is the origin. So from the origin, the position vector of the point L, that is OL vector that is given as 2a vector minus b vector, and the position vector of the point M, that is OM vector, that is given as A vector plus 2b vector. Then we have to find the position vector of a point N which divides the line segment LM in the ratio 2:1 externally. You have to find the position vector of some point M. You have to find the position vector of some point N which divides LM in the ratio 2:1 externally. So it means that LN is to NM. Ln is to NM, that is equal to 2:1. That should be equal to actually minus 2:1. Since that is external division. So here we have to use the section formula. So according to the section formula, the rule is that if any point C that divides AB in the ratio m:n, AB in the ratio m:n, it means suppose AC is to BC, that is equals to m:n. It means AC, the length AC divided by the length BC, that is equal to m by n. This length is m, this length is n. So then if the coordinates of the point, and if the position vector of the point A is given as A vector and the position vector of the point B is given as B vector, and the position vector of point C is C vector, then C vector will be equal to m A minus n B divided by m minus n. So here AC is to BC, that should be minus m:n, means if the point C, this is OC vector. So if point C divides A and B externally in the ratio m:n. Okay. So this is the rule which you have to apply. So this is ON vector. So therefore ON vector will be equal to, this is written, so therefore LM is to NM, that is 2 minus 2:1. So we can tell this is, or we can write 2 is to minus 1 also. So it would be 2 into OL vector minus 1 into OM vector divided by 2 minus 1. So therefore ON vector, that would be equal to 2 OL vector minus OM vector. So therefore ON vector, that should be equal to 2 into OL vector, which is 2A vector minus B vector. Then minus OM vector, which is A vector plus 2B vector. So then ON vector, that will be equal to 4A vector minus 2B vector minus A vector minus 2B vector. So this ON vector, that should be equal to 3A vector minus 4B vector. So this is the required position vector of the point N. Therefore, the required position vector of the point N is 3a vector minus 4b vector. So this is the final answer. Thank you.